Hello, my dear friends. How are you all? Hope your study is going very well. So now I'm going to start your that math one that you are studying in your first semester, named as calculus. So in your calculus, your first module is sequence and series. So first, before starting the sequence series, we will deal or we will recap some what you have already studied or some introduction part. Okay, so I'm starting with real numbers. So we already studied from many when since childhood we know that the natural numbers we denote by the number n, by the symbol n, which contains the elements like 1, 2, 3, 4, like this, and the set of real numbers which we denote by the symbol r. This is the combination of both rational and irrational numbers. You all know about this. What is rational number? What is irrational number? Rational number are those. Means how can you distinguish rational number? If some people may not know, then I'm just telling in quick, in brief. A number, if a number, suppose x, I will call this number as a rational number or irrational number. How can I know? If a number is a rational number, then it should satisfy three conditions. So my first condition is if I can write in the form of p by q, means I can write, if this x is a rational number, then I can write this in the form of p by q. What is the second condition? My here the q, my denominator should not be equal to 0. Clear? And what is my third condition? My third condition is this numerator and denominator, this p and q, both should be integers. What are the integers? Integers are nothing but 0, plus minus 1, plus minus 2, plus minus 3, like this. So if a number satisfy all these three conditions, then only I will say this number is rational number. Otherwise it is irrational one. For example, let's take a simple example. Suppose root 2. I have to say whether it is rational or irrational. So I will check first the first condition. What is the first condition? I should write this in the form of p by q. Can you? Yes, I can write this root 2 as root 2 by 1. Is it clear? Yes, we can write any number. Na? So my first condition is satisfied. Let's take the second condition. What is my q here? My q is 1. Is it equal to 0? No, this is not equal to 0. So my second condition also satisfied. Okay. Now comes to third condition. What is my third condition saying? Both p and q both should be integers. But if you check this 1 is an integer. But the root 2 or root over of 2 is not belongs to z. So my root 2 is not a rational number. Clear? I think you are already studied in your intermediate. No need to tell any more on this topic. Let's continue more on our topic. Means what we are going to study. This is Z. N clear, R clear, Z clear. Now I am going to some sets part. You have already sets. Okay, sets. In sets you come across one term that's called subsets. In set you studied one term that is subset. What is subset? Suppose this is a big set. If any set I can represent within this, if any set I can represent within the big set, then I will call this B as subset of A. Okay, or I just tell in that form of Venn diagram. But what is the mathematical form? If we consider any x, if x is belongs to B, then my x should be belongs to A. Then only I can say B is subset of A. Okay, these things you know, so no need to explain. So let's consider some subset of real numbers, and whatever we study will mainly focus on real numbers. Will not go beyond this. Like complex number will not study. For complex number there is separate separate course, complex analysis. So we'll not study that. We'll focus only on real numbers. So let me give you some examples of subset of real numbers. Can I say, suppose A is a set, its contents like -3, -2, -1, 0. Is it a subset of real set, real number system? Yes. Okay. If I can write another set, suppose 5, 7, 8. This B is also subset of R. Okay. This is clear. Very basic thing. Now let me ask you two questions. Okay. Let me ask you two questions. My first question is, can you tell me any number? I'm considering this set. Okay. So forget about this. I am keeping this as A. Let this be B. Achha. Can you give me example of any number which is greater than or equal to every number in the set A? I'm again repeating. Can you give me example of any, only one, at least one, or more than that? I'm saying only at least. And again I'm saying you will come across two words. One is there exist or at least, and symbol for that this one. And this symbol denotes for all. This symbol is either there exist, this is there. This symbol is there exist and this symbol is for all. We will come across this symbol or this word many times. Okay, that's why I'm writing this is there exist, or you can say for at least one. Okay, what I was asking, is there any number in the set of real numbers which are greater than or equal to every number, every elements in the set B, in the set A? Can I say 8 is a number? Understand? If you don't understand the language, so if can I say this 8 is greater than or equal to every elements in the set A? Are you getting? Similarly, I can say 9. 9 is also greater than every element. I am saying greater than or equal to. I am saying greater than or equal to. It does not mean always greater than equal to. It may be greater than or it may be equal. For this, for suppose 8, it is greater than 5. It is greater than 7. It is greater than 5. It is greater than 7. But it is equal to 8. Okay. But if I say 9, it is greater than all of the 3. So if there, so what I was asking, is there any number you are finding in the set of real number which is greater than or equal to these elements of this set? Yes, you can get 8, 9, you can say also 10, 11, like this. There are infinite number are there which is greater than or equal to every elements in the set, in this set. Is it clear? Similarly, if I will ask you, is there any number you can find in the set of R? Any number. Suppose this number is X. Can you find any number in the set of real numbers which is less than or equal to of these elements of this set? Yes. Can you find 5? If I say 5 is less equal to this, but it's less than and less than of both. So 5 is a number which is less than or equal to every elements of this set. We can also say 4, 3, 2, like this. Is it clear? Okay. So if for any set the number like this exist, means the number which are greater than or equal to every number of this set, then I will call my set is bounded above. Then what will I call? My set is bounded above. Okay. If suppose X is any elements of A, X is any elements of A, what is A? A is subset of R. If X is any sub element of A and I have to find there exists at least one. I'm not saying more. It may there is at least one, means there may be one or more than that, but we have to find at least one. Okay. If there exists at least one, I'm saying U. Suppose there's I'm denoting. Suppose I can write this in the form set. I can write it in the form set. I'm denoting it U. Okay. I can write it in this also another set. I'm writing it in as L. Okay. If I can find a U and it's the element of U I am representing in terms of small u. Okay. And the element of A I am representing in terms of X, and I will represent the elements of L as small l. So if there exists a U which is greater than every element of this, means U should be greater than X. And what is my U? U is belongs to R. If you can find any U which is belongs to R is greater than or equal to X, then only I will say my set A is bounded above. Clear? Clear one? So my set is 5, 7, 8. I can find this number 8, 9, 10, 11, 12 like this, which are greater than or equal to every number of this set. So my set A is bounded above. Similarly, if you find such numbers which are less than or equal to every elements of this set, then I will call, if same thing, if my X belongs to A, okay, if there exists at least one L, I am denoting L for these elements which is less than equal to every element of X. And what is my L? L is any real numbers. Then only I will call my A as bounded below. I hope this is clear. I hope this is clear till now. Now, what is bounded above, bounded below? You understand? And what are these number? This number, I will call this number as upper bound. I will call this number as upper bound of this set A. Understood? If this number exists, then bounded above. What are these numbers? These numbers are upper bound of A. What is this? And I will call this as lower bound of A. I will call this as lower bound of A. Understood? Means bound में हम क्या बोल रहे हैं इधर, means what we are saying, means my set, suppose this is my set, it is bounded, means it is remaining within this bracket, not bracket, it is remaining, means all the elements are residing within this and this, means it is bounded. Understood? And if you remark one thing, in this upper bound set, there exists a number which is less than or equal to every number of this set. Yes, means in short I can say there is a number, or in the upper bound set there is a upper bound which is least among them. There is a upper bound which is least among them, and I will call this as least upper bound, and I will call this least upper bound. Similarly, in the lower bound set, there exists a number which is greater than equal to every number of this set, of this lower bound set, or I can say there exists a greatest lower bound. There exists a greatest lower bound which is 5 here. Okay, I will call this greatest lower bound. So for this set, what is the least upper bound? Least upper bound is 8. What is the greatest lower bound? What is the greatest lower bound? It is 5. Okay. What is this? This is 5. I hope this is clear. What is bounded above? What is bounded below? Upper bound of what is the upper bound of A, what is the lower bound of A, and in the upper bound there is a upper bound which is least among them, that is called least upper bound, and there is a lower bound that which is the greatest among them, that is called greatest lower bound, and we can write in short as L U B for least upper bound, and for greatest lower bound we can write G L B. For suppose you have a friends. Suppose you have a friends named as either least upper bound or greatest lower bound. You have friends, and somehow he is crossing the road, and you saw that one truck is coming and will hit him. But your friend, he or she, is completely unknown about this. You don't know that he is busy with phone. So what will you call? What will you call him? Least upper. Khatam. If you call only least upper, by this the dog will hit him and you can't survive your friend. Your friend will not survive. Means, are you getting what I mean to say? Means least upper bound, greatest lower bound, these names are very big. We'll use short name. Okay, we'll use short name. For this least upper bound, I will call this as supremum. I will call this least upper bound as supremum, and the greatest lower bound I will call as infimum. I will call the least upper bound as insert supremum and this greatest lower bound as infimum. And I will write this also in very short. How? I will write this supremum as SUP and I will write this infimum as INF. Okay, I will write the supremum as SUP and I will write the infimum as INF. So can you say for me, for this set A, not for me, what is the supremum of this set? Supremum of this set is 8. Clear na? I hope clear. Supremum is least upper bound. What are the upper bound of this set? The upper bound of this set are these. What is the least among them? 8. So my supremum is 8. So this is my supremum. And what is the infimum here? My infimum is 5. Clear? Okay. So can you tell me which is supremum and infimum in this set? In this set, you have to find the upper bound. What are the upper bound for this set? For the set B, what are the upper bound? Upper bounds are 0, 1, see, -3, -2, -1, 0. Upper bound means it should be greater than or equal to every elements. 0, 1, 2, 3 like this. What is the lower bound? Lower bound, see, -3, this is -3. So -3, -2, -1. Okay. So which is the least among these upper bound set? 0. So this is my supremum. What is the greatest? This one. Sorry, I'm very sorry. This is not -2, -1. This is -3, -4, -5. Because all numbers should be less than this, na? Yes. What is the greatest among them? Is -3. So -3 is the infimum. Understood? And let me clear to you some basic things. Can you say, is the upper bound or lower bound of a set is unique? I am asking upper bound and lower bound. See, for this set or for this set, are there any one upper bound? No, na? There are many upper bounds. See, for this set there are many upper bounds. So the upper bound or lower bounds are not unique. There may be infinity number of infinite. Okay. And also lower bound is not unique. And also another one thing, the upper bound and lower bound, it is not necessary that it should remain in the set. It is not necessary it should remain in the set. For example, see this 9. 9 is upper bound of this set. This 9 is UL. This U and L for this A only. This 9 is not in this set, but it is an upper bound of this set. So for the upper bound, it need not to be in this set. Same for lower bound. Okay. Now we'll solve some more examples for clear understanding of this concept. Achha. Now let me tell. Achha. Let's say suppose n. One thing I forgot to tell. Suppose a set is bounded above. Bounded above means understood na. There exists at least one upper bound, and as well as bounded below, and as well as bounded below. Once listen. Suppose we solve in 12th class in our intermediate 11th 12th. If left hand limit of a function exists and as well as right hand limit of a function exists, then only we can say limit of the function exists. Similarly, if a set is bounded above as well as bounded below, then I will call my set is bounded. What will I call? My set is bounded. Simple say beta. Nothing. If a set is bounded above as well as bounded below, then I will call my set is bounded. Okay. Now we will check some set whether they are bounded or not. If it is bounded above, what is the supremum? If it is bounded below, what is the infimum? Now consider the set of n natural numbers. What is this set of natural numbers? Like 1, 2, 3. Can you find lower bound for this set? Yes, of course. What are the lower bound? Lower bound, I am writing the lower bound set as L. What are the lower bound? 0, -1, -2. Again, I am repeating this lower bound. All the lower bounds would be belongs to R only. And what are the lower bound? This. So is it bounded below? Yes. So my set N is bounded below. And is there in N? What is the greatest lower bound? 0. 0 is greater na among them. So my 0 is infimum. Okay. So can you find any number which is greater than equal to every number of this element? Which is greater than or equal to every number of this element? You can find. But you can't say that infinity. You can define any relation between infinity and infinity. Have you ever seen infinity? Have you ever seen infinity? You have seen, I think, in book or in your notebooks while writing or solving some problems. But somehow I saw a 100 rupees where it has written that, "Dear infinity, where are you? Please come and call me. This is my numbers. This is my number. Star 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 10 star. If anyone find infinity, please contact." Okay. Sorry, beta. Just magic. What I was telling, that you can't define any relation between infinity and infinity. You can't say infinity is greater than infinity or infinity is equal to infinity. So there will no upper bound. There is no upper bound. So is it bounded above? No, it is not bounded above. It is not bounded above. So it is not bounded. Clear? Is it clear? Okay. So similarly, you can think for Z, set of integers. You can think for Q, rational number, irrational numbers. You can also think for real numbers. Okay. There is, these sets are neither bounded above nor bounded below. All these sets are neither bounded above, neither bounded above nor bounded below. So you can't get any supremum or infimum here. Just think and you can do this z, integers q, you can't get any lower bound set, you can't get any upper bound set. Okay, I hope this is clear for you all people. Sure. But I am writing some real numbers. Okay, suppose -5, let's say 2 0 -3 3 3 192170. Okay, can you write any number, any natural number which is greater than this number, or this number, or this number, or this number? For example, if I say 5, can you write any natural number which is greater than -5? Yes, 1 is greater than. I'm saying at least 1. No need to write all. If you write, I can't write all in a single word. Achha. For 2, is there any natural number which is greater than 2? Yes, I can write 6. Any number, at least 1 chahiye na. For 0, I can write 111. 111 is greater than this number. For this, I'm saying natural number. What are these? These are natural numbers. These were real numbers. Okay. So for -333, I can write 3. 3 is a number which is greater than this number. For this, I can write 192171. Okay. So what we are seeing, for every real number, there is a natural number which is greater than this. I just took 5 example. You can take any number of example, n number of example. So if I say in general, x is a real number, x is a real number, and n is a natural number. Okay, so I can say for every x belongs to R, means for every real number there exists. I told you this symbol denotes there exists. There exists a natural number. What is this n here? N is a natural number. There exists a natural number which is what is this n? N is greater than x. Understand? Understood? See here. Here 1 is greater than -5, 6 is greater than 2, 1 is greater than 0. Understood? Na? Means whatever x you will take, there will be always a natural number which is greater than that real numbers. And this property is shown by the real numbers, and we will name this property as Archimedean property of real numbers, and this property is known as Archimedean property of real numbers. Understood? Simple hai na? For every real number there is a natural number which is greater than this. Okay. Now let's come to some, I think you all know about absolute functions. What is absolute function? F of x, and we write mod x, modulus function. What is this function? This is equal to x if my x is greater than equal to 0, and it is equal to minus x if x less than 0. Yes, you know. For example, what is mod of -2? This my -2 is less than 0. So what is mod of x? It is equal to minus of -2 is equal to 2. You know this, and this also you know. For example, if mod x is less than epsilon, what is epsilon? I am assuming some numbers or some variable, all are real numbers. Okay, I am assuming these 4 variable, means that's 4 variable I am going to use now. These all are real numbers, and this epsilon is greater than 0. Okay, I am assuming these all are real number, but this epsilon is a positive real numbers. Okay, so for if mod x is less than epsilon, then can I write this ax should lies between minus epsilon to epsilon? Do you understand? What do you understand? I did not explain anything. Let's see. Suppose my mod x less than epsilon. Okay, my mod x means there are two cases. It either greater than equal to 0 or less than 0. Suppose for x is greater than equal to 0. If x is greater than equal to 0, what is the value of mod x? X. My x is less than epsilon. Clear? Clear, no? There is another case when x is less than 0. If x is less than 0, what is mod x? Mod x is minus x. Minus x is less than epsilon. If I multiply minus sign both sides, then the sign will change. This greater than will change to less than. Combine these two. What will you get? Minus epsilon less than x less than epsilon. Is it clear? Do you remember? Yes. Understood, no? Okay. So if I say mod of x minus a is less than epsilon, similarly, what can you write? This my x who lies between a minus epsilon to a plus epsilon. In the same way, you can prove. Okay. And you already proved in your vector when you already studied vector in your intermediate. What is mod of x plus y? It is less than equal to mod of x plus mod of y. Similarly, what is mod of x minus y? It is greater than equal to mod x minus mod y. You can take example like take anything, na? x y a epsilon, all are real numbers and epsilon is greater than 0. You can take any example, take x equal to 2, y equal to minus 1, anything you can take and just put and check whether these conditions are satisfying or not. This is one. Let's see another thing. Can I write x as x minus y plus y? Is there any problems? No, na? Okay. So what will be mod x? Mod x will be mod of this one. Just simply I put mod both sides. See here, mod of x minus y is less than mod of x plus mod of y. I am considering these such x and these such y. So this will be what? Less than or equal to mod of this one plus mod of this. Clear, na? This is whole my x. This is my y. So this total equal to, see here, compare. This is equal to less than equal to mod of x minus y plus mod of y. Okay. So can I write, if I take this mod y this side, what will happen? Mod of x minus mod of y less than equal to mod of x minus y. Clear? Similarly, I can write mod of y equal to mod of y minus x plus x. Okay. In the same manner, similar manner, I can write mod of y minus x plus mod of x. If I will take this side, this is mod. Okay. What will happen? Mod of y minus mod of x less than equal to, you know what is mod of y minus x, and this is also same as mod of x minus y, na? What is the mod of 2 minus 3? It is also equal to mod of 3 minus 2. So mod of y minus x, I can replace it by mod of x minus y. It is mod of x minus y. Okay. These are the few things that you already know. You might think, other than what I am teaching, you are telling only you know all. Okay. But these are just basic. Today I will explain all the basic thing. On the next day, I'll start the actual things. Okay, the main things. But today is also important. Just understand the basic. If you don't understand the basic, how can you go to the next part? Okay, so I'm starting your first chapter, that is sequential series. The introduction part is over. So your first chapter is sequence. So your first chapter is sequence. Is there anyone who remembers what is sequence? What is sequence? Sequence. Yes, what is sequence? Sequence is nothing but it is a function. Sequence is a function which is defined or whose domain is natural numbers. Khatam. What is sequence? Sequence is a function whose domain is natural number. But as I told, whatever we'll study only real numbers. Means we'll study only real sequence. So I am adding here real sequences. We will not study one sequence. So this is real sequence. So what is real sequence? We are studying about real sequence. What I am telling, it is a function from natural numbers to real number. Okay, so I can denote it in the form of diagram. Suppose this is my domain, this is my range. Already told, in a real sequence my domain is natural number, range is real numbers. I can define this is a function. What are the domain? Domain are the natural numbers, means I can take 1, 2, 3 like this. What are the range? Means every element has an image. For 1 the image is like f of 1. For 2 I can write f of 2. For 3 I can write f of 3, like that. Okay, and I will call this f of 1 as a1. I can denote f of 2 as a2, f of an as an. I will call this as first term. I will call this a2 as second term. Similarly, this an as nth term of the sequence. So in a sequence, how many terms are there? In the sequence, domain is natural numbers. So in how many number of natural numbers are there? Infinity. So how many terms in a sequence? Infinity. Because this much domain, now you will get that much range. It is not necessary that all domain has to have a range in a function. I think you have remembered. Then sequence things over. Let me give some examples. Suppose f of n is -1 power n. So what can you write? How can you write the sequence? And this term a1, a2, an, and we will denote the sequence as an, or we can denote like this. What is an? An is natural number. Here n is also natural number. We can denote either this way or this way. So here what will be my sequence? My a1 will be f of 1. F of 1 will be -1 power 1 is -1. Similarly a2, what is a2? F of 2. F of 2 means 1. What is a3? F of 3. What will be f of 3? -1 power 3 means -1. Like this you can write all the terms in the sequence. If I say another example, my f of n, suppose k, or I can write an as f of n. So what will be f of 1 means a1, a1 will be k, a2 will be k, a3 will be k. So this type of sequence I will call as constant sequence. There are some basic definition like monotonically increasing, monotonically decreasing. I think you all have heard about this word. One is called monotonically increasing sequence. Monotonically increasing sequence. Another is monotonically decreasing. What is monotonically increasing sequence? If my n plus 1 term is greater than equal to nth term, then I'll call this monotonically increasing sequence. Similarly, what is monotonically decreasing? If my n plus 1 term is less than equal to nth term. Okay. Similarly, straightly increasing and straightly decreasing. These things you already learned about this. Learned about these things. Straightly increasing. Another is straightly decreasing. If my n plus 1 term is greater than nth term, then I will call straightly increasing. And if my n plus 1 term is less than nth term, then we call this straightly decreasing. Okay. Then whatever you studied in the set, like what is upper bound, lower bound, the same things also per sequence we will study, but I will not repeat again. Suppose n is the sequence, I will call a number m. If m is belongs to R, if m is greater than for every elements of the sequence, then I will call this upper bound. And the same way, if there exists an small m, if it is less than equal to every elements of the sequence, then I will call this as lower bound. In the set we define, suppose A is a set, we define its upper bound set, we define its lower bound set. Okay, I am denoting all the elements of set A as X, all the elements of set U as small u, all the elements of set L is small l. Okay, and we also define one is supremum and infimum. I am denoting supremum as m and infimum as m. And I think till now you must have cleared this m should be greater than or equal to x, and it should be less than equal to u. Means my m will lies here. My m should be greater than equal to x and less than equal to u. Similarly, my infimum, it should be greater than equal to l and less than equal to x. Clear now? Because it is the least one, na? It should be less than all the elements. It is the greatest one, it should be greater than of all the elements. As it is lower bound, it will be obviously it will be less than. As it's upper bound, it will be greater than. So can you find? If I will ask you in any finite sequence, finite sets. So any finite sets. So any finite sets like 1, 2, 3, 4, 5, 6, anything you will consider, then you will get it as bounded. That means it is bounded above as well as bounded below. So every finite set is bounded. Okay. So my last question before ending the class, that if my sets is 1 by 1, 1 by 2, 1 by 3, like this, whether it is bounded or not, tell me in the next class. Till then, goodbye. Thank you.